Okay, now we're going to go on to the chapter of moments, and this is actually about the turning effect of a force. Okay, so moments is actually about the turning effect of a force. So just take note of this. Now, why? Why is the doorknob always placed furthest away from the hinge? Okay, we talk about doorknob. You can see here, the doorknob is placed furthest away from the hinge compared to if it is near. Okay, so why is it difficult to open the door if the knob is near the hinge? Obviously, if this is a chapter on moments, so the answers to this is because of the word moments. So it's about the turning effect of a force. Okay, turning effect of a force. So now, since the door is fixed at hinges, we call this point the pivot. So a pivot is a point of a system that is fixed while the rest is free to turn. So example, the hinge here. Okay, this is actually where the pivot lies. So you can see that this is the fixed point and the door is free to rotate about the fixed point. So the hinges is where we call the pivot. So the pivot is a point of a system, okay, that is fixed while the rest is free to turn. So you can see here this is the pivot. Now, so what determines the effort needed to open a door? There's actually two factors here. So the first one is the force exerted by us. So we talk about the force exerted. Okay, so underline, highlight, force exerted. The other one we talk about is the how far the knob is from the hinge. So we say the distance of the force away from the pivot. Because we know that we exert the force at the pivot, we exert the force at the doorknob. So the distance of the force away from the pivot is actually under part 2. We talk about how far the doorknob is from the hinge. It will determine the turning effect of a force. So these two factors combined, okay, will give rise to a new quantity measuring the turning effect of a force. Okay, let's use a nice blue color. And this is actually termed as moment. So the turning effect of a force, okay, is dependent on two things. One is the force exerted. The other one is the distance of the force away from the pivot. Okay, these two factors combined together will tell you how much turning effect of the force there is. Now, so let's move on to the start of the whole thing here. We define what is a force. What's the turning effect of a force, in this case moments. So the definition of moments is the product of the force and the perpendicular distance from the pivot to the line of action. Okay, so the key points here is a product of what? Of the force and the perpendicular distance. Alright, let me change the color. Perpendicular distance from the pivot to the line of action of the force. Or you can think of it as perpendicular distance from the pivot to the force. Okay, so this is the definition of your turning effect of a force. So it's a product of a force and the perpendicular distance from the pivot to the line of action of the force. Because we must term what we mean by perpendicular distance. So let's take a look at this. Now, so this is the door. Okay, you can see here this is the hinge. Okay, the pivot is actually at the point where the doorknob is here. The pivot is actually where the hinge is located. So the force exerted, think of it 3D. Okay, so the guy is pulling the door towards himself. The perpendicular distance is from the hinge to the door, and the force exerted is depending on how hard he pulls. And these two factors combined together, we term it as the turning effect of the force, okay, which is also known as your moments. Okay, so as long as anything turns, yes, that is moments. Okay, now, so obviously this is the one thing you must know. We come to the point of physics where you'll see formulas. Okay, formulas help us to determine the exact amount of the quantity. So for the moments of a force, okay, we talk about moment of a force. Okay, it's actually the force exerted multiplied by the perpendicular distance from the pivot. The SI unit, this is important here, it is Newton meter. So take note, most of the time we will tend to convert the perpendicular distance to meters. Okay, always convert to meters. Okay, please do not forget this. So the moments, you must always take the force in newtons multiplied by the perpendicular distance in meters. So you will be able to get the SI unit of Newton meter. So we went on to the formula already. So this marks the end of part 1. Okay, we talked about what is the turning effect of force. We went on to talk about what are the factors of it, and then we talked about its formula. Okay, in the next part, we'll look at how do we calculate it.